Good morning. Today is June 21, 2020, and once again this is Teacher Ariel. Our subject is measurements and experiments. Our topic for today is basics of oscilloscope and on how to compute given problems on time and frequency. Understanding oscilloscope screen graticule. This is just a review of our previous lessons last week, just to remind you of all the important things to be considered in studying the screen or display of the oscilloscope. So here is the display, the graticule, 8 by 10 centimeters, meaning 80 boxes inside. We have the vertical line as the y-axis that represents the amplitude or voltage. We have the horizontal line that represents the x-axis, means times in seconds. We have the peak voltage, positive peak voltage. This is the upper portion of the vertical axis. Then we have the negative peak voltage, which is located at the bottom of the vertical axis. Then we have the complete set of the peak-to-peak voltage, including the up portion and the lower portion of the display vertically. Now let us concentrate on the horizontal part of the display or the graticule of the screen. So what are the things to be considered in studying the horizontal part of the display? We need to consider the time per division knob, which can be set to seconds, milliseconds, or microseconds. And also, we need to concentrate on the following formulas, wherein we have frequency, or F, is equal to 1 over T, which is time, or time is equal to 1 over F, or 1 divided by frequency. Then, here are some transmutation, like for example, 1 second is equal to 1,000 millisecond, or 1 second is equal to 1 million microseconds. The horizontal axis represents the time in second, and also very important in computing for the frequency. Let us proceed. Example, the time per division knob is set to have a 1 second. Then the signal has a duration of 4 boxes to complete the complete cycle, or 1 cycle. So 1 cycle, for example, occupies 4 boxes horizontally. So we have here 4 boxes to complete 1 period of time. So we have the formula that time is equal to time per division times the number of boxes. Since our example is 1 second, so 1 second times 4 boxes, we have 4 seconds. So 1 cycle, in this example, 1 cycle has a time of 4 seconds to complete the 1 cycle in this example. Next, we have another example. Time per division is set to 10 millisecond. So since this is in millisecond, you need to convert this millisecond to second. So we have 10 millisecond is divided by 1000 is equal to 0.01 seconds. This is very important. You need to convert this to seconds. If the expression is in millisecond, you need to transpose this or convert this to second. If this is in microsecond, also you need to transpose or convert this to second. Now, in this example, 1 cycle covered at least 1, 2, 3, 4, 5 boxes. So to complete 1 cycle, the cycle one cycle occupies at least 5 boxes. So in order for us to compute for the time is equal to time per division times number of boxes is equal to time equal to 0.01 second times 5 boxes, we have 0.05 seconds. Okay, then another example, our time per division knob is set to 200 microseconds. So 200 microseconds, then let us convert these 200 microseconds to seconds. So 200 microseconds divided by 1 million is equal to 0.0002 seconds. Now, in this example, one cycle occupied or has a period of 6 boxes, 1, 2, 3, 4, 5, 6, meaning these 6 boxes covered the one cycle. Okay, so time is equal to time per division times number of boxes. We have time is equal to 0.0002 seconds times 6 boxes is equal to 0.0012 seconds. So this is our time. Now, to further understand my explanation, let me put some signals in this display. Okay, now let us go back to our first example. So again, the knob is set to 1 second. Then we have a sine wave. This red sine wave represents as 1 cycle. So this 1 cycle sine wave occupies a period of 4 boxes. 1, 2, 3, 4. 4 boxes. So to compute for this, we have time is equal to time per division times number of boxes. So we have time is equal to 1 second times 4 boxes. 1, 2, 3, 4. So we have 4 seconds. Now the formula for computing for the frequency, we have F or frequency is equal to 1 divided by time. So since we have 1 divided by 4 seconds, so we have 0.25 hertz, or we have 1/4 hertz. So the frequency is 0.25 hertz. Why? Our formula is frequency is equal to 1 divided by time. So 1 divided by 4 seconds is equal to 0.25 hertz. That's how we are going to compute for the frequency. Here is the formula. Here is the computation of the time, and that's it. The next example was the time per division is 10 milliseconds or 10 ms. So we need to convert this to 10 milliseconds divided by 1000 is equal to 0.01 seconds. Now, this sine wave or sinusoidal wave has at least 5 boxes. The time covered in this one cycle, to complete this one cycle from 0 then going to 360. One cycle has 5 boxes. Again, our formula is time is equal to time per division times number of boxes. Time is equal to 0.01. 0.01 times 5 boxes is equal to 0.05 seconds. So our time is 0.05 seconds. To compute for the formula, we have F is equal to 1 divided by T or time. So 1 divided by 0.05 seconds is equal to 20 Hertz. I hope you can follow this second example. It is very clear. I make it very simple for you to understand. And let us proceed to the next example. In this example, the time per division knob is set to 200 microseconds. So again, since this is a microsecond, we need to convert this to seconds. So we have 200 microseconds divided by 1 million is equal to 0.0002 seconds. Now, in this example, our one cycle of sinusoidal wave or sine wave has a period of 6 boxes, meaning this sine wave covered at least 6 boxes or 6 divisions of the display. So on how to compute for the time, again, time is equal to time per division multiplied by the number of boxes. So in this case, we have 0.0002 second times 6 boxes or 6 division, 1, 2, 3, 4, 5, 6. So our time is 0.0012 seconds. Now to compute for the frequency again, F is equal to 1 over T or time. So 1 divided by 0.0012 second is equal to 833.33 Hertz. Okay, so this is our frequency. So meaning it has 833.33 cycles per second. So in 1 second, it has 833 plus times of this kind of signal or frequency. Like for example, in our outlet, AC outlet, it has 60 Hertz, meaning 60 times per second. 60 repetitions of this cycle per second. Do you understand? Okay. Now, assignment. Compute for the time and frequency of this given problem. I have here at least 3 problems for you to compute and to be submitted to me on our next online meeting. Okay, another problem, then another problem. Let me go back to the first problem. Okay, the time is set to 40 milliseconds. You need to compute for the time or period, then compute for the frequency. All the information needed for you to compute this problem was discussed to you a while ago. Problem again, number 2. The time is set to 100 microseconds. Again, you need to compute for the time and also for the frequency. By the way, this is a triangular wave or triangle wave. This one is a sine wave or sinusoidal wave. Triangle wave. Then we have also sine wave or sinusoidal wave. In this problem number 3, we have 100 milliseconds. So again, to remind you, you need to convert this to seconds for you to proceed in your computation. And also, you need to compute for the time and frequency. Again, you are going to submit this on our next online meeting. I make this red for you to make it as a reference that you are going only to compute for this, because these are only repetitions of this red color signal, sine wave. As you can see, 1, 2, 3, 1, 2, 3, 1, 2, 3, the same. So just focus on the red part of the signal, because the blue one are only repetitions of the signal. So what will be our next week topic? It will be a follow-up lesson, and we are going to combine or a combination of peak-to-peak voltage, time, frequency computation, as well as we will have a new computation of the VRMS. Thank you very much.